All right, guys. I wanted to make this short video here. We are going to get into some of the topics that we're going to see in the next unit. So we'll kind of work on that for today. And a big piece of what we're going to see in this next unit involves factoring some different terms that we have seen before. And so being able to do this and getting a refresher of how to factor problems like that look like this are going to be the main focus of what we're going to see in Unit 9. So what I'm going to have you guys work on for today is this factoring review worksheet. And I'm going to do a few of the problems in this video real quick just to give you a refresher of how to factor these completely as it says. So starting off with number one, I'll go ahead and do that one. Remember when we were factoring, one way that we talked about organizing these values was by setting up the box method, where I would set up a 2x2 box and I would place these values inside of it. So we always take the first value and we place it inside the top left box. We used to take the last number and place it inside the right box. And then we had to set up what we call the X method here to figure out what should go in these remaining two boxes here. So the way the X method worked is we always said that we would put A times C on the top of the box, and that is what these two values that we're going to try to figure out are going to multiply to. And then we always put B on the bottom. That is what these two values are going to add to. And as a reminder, if this was a quadratic, this is in the form of ax squared plus bx plus c. So a is the number in front of r squared, b is the number in front of r, and then c is the number at the end here. So if I did a times c, a is technically 1, so I don't have to write that, but a times c would be 1 times 4, which is 4. On the bottom, we would have b. B in this case is just negative 5. So in other words, I need to figure out two numbers that multiply to 4 and add to negative 5. And in this case, those two numbers would be negative 1 and negative 4. So that would be the values that I'm placing inside the box now in front of a variable. So this first box here could be negative 1r, and if that was the case, then the other box would have to be negative 4r. And then the last thing that we said is once we have everything inside the box, we're going to figure out what has to go on the outside to create each of these cells. And each of these cells is created by multiplying the row times the column. So for instance, if I have r squared in the top left box, the only way I could get that would be by multiplying r times r. So those have to go there. And then remember, these should be pretty easy now. R times the thing that goes above this column would be negative 1r. So that number has to be negative 1. By that same notion, r times what goes on this row here would give me negative 4. So that value should be negative 4. So what I have for my final answer here is these two factors that are on the sides of the box. So I have r minus 1. That is one of my factors. And then the other side of the box, r minus 4. And that is how we talked about taking something that looks like this and factoring it into two different things that are being multiplied together. If you need to use the box method and the X method to set these up and organize where everything goes, because it helps you, feel free to do that. If you can look at a quadratic like this and understand how to get the two values that come from it, feel free to just write that answer if you can do that in your head. Okay, so that is number one. I want to skip down to number 7 because we have another type of problem that we've seen that's very similar. But this one is missing a term that's in the middle. Okay, there's nothing that says in the middle here. And so how I would do this is same kind of idea. I would set up the 2x2 box. I would still place the squared term in the top left, the number in the bottom right. And if I was setting up the X to figure out what's going to go in these remaining two boxes, the thing that these two numbers are going to multiply to is a times c. Well, a is right here. That would technically be 1 again. C in this case would be that number at the end, which is negative 25. So a times c would be negative 25. The part where it's a little bit stranger is on the bottom of the X, I usually put b, which is the number in front of in, but there is no term that says in. And so if that's the case, we talked about how I just want to put a 0 there. So I would need to figure out the two numbers that multiply to negative 25 and add to 0. And those two numbers would be negative 5 and positive 5. So that means I'm going to fill in one of these boxes with negative 5 in, and the other box with positive 5n, and then find what goes on the outside. So if I have n squared in the top left, that would be created by multiplying n times n. If that is the case, then this top column would have to be -5, and this bottom row would have to be +5. So what are my two factors from this? Well, I have one side of the box, which is n minus 5. The other side of the box, n plus 5, since that is a positive 5 right there. And that would be my final answer. So just remember on these, when the middle term is missing, just make sure you understand that b is 0. Okay, and then last one, well, let's do a few actually. I want to do number 12 as well. So number 12, we have something like this, 5n squared minus 35n plus 60. So same kind of idea, we will set up the box method. But one thing that is going to help you is when you start to have something in front of the squared term, check and see if there's a greatest common factor between these three numbers that you could factor out. In this case, 5 does go into all these numbers, so you could actually factor that out. So I would put a 5 on the outside, and then I would write what's left over if I divided every term by 5. So that would give me n squared now, minus 7n, and then plus 12. And now this problem is a lot easier. Instead of plugging 5n squared into this top left box, now I'm just focusing on what's in the parentheses, and I would just plug in n squared in the top left box. I'd plug 12 in the bottom right. We'd go ahead and set up the x method. These two things are going to multiply to a times c, so 1 times 12, which is 12. These are going to add up to the middle term, b, which is -7. So what are the two numbers that multiply to positive 12 and add to -7? That would be -3 and positive 4. So that's what I'm going to fill into the box, -4n, -3n. We've got n, we've got n. This has to be a -4, this has to be a -3. So my two factors here are n minus 3 and n minus 4. And then one last thing to not forget is there was a 5 out front from the very beginning. It's not that it goes away, it just stays in front of your final answer here. Okay, so I did want to go through one of those where you had to take out the greatest common factor first. Okay, and then let's try to find one more where there's not going to be a greatest common factor that you can take out, like number 15. So on number 15 here, we have a quadratic again. So again, same box method here. First term of the squared term in the top left, number in the bottom right. And the reason I'm writing these just right away and not trying to take anything out of it is because there's not a greatest common factor that goes into 3, 31, and 56. So I'm going to have to write them like this. So now I use the x method here to figure out how I'm going to break up this term between these two boxes. So what they multiply to is a times c, so 3 times 56. Let me see if I can get a calculator real quick. I believe that's going to be 168. Yep, 168 here. And then on the bottom is what they add to, which is 31. So I would have to take some time and try to test out some different values. That would be factors of 168. So like for instance, 1 and 168, 2 and what would that be, 84, things like that. And I would just start testing out some different values until I find some that add up to 31. And I believe if I divide this by 7, I end up getting 24. And so those are actually my two numbers here, are 7 and 24. And some of these might take a little bit of time where we might have to test some different values to eventually get the ones that we need. So my numbers are going to be 7 and 24. So I'll go ahead and put 7K in one of these boxes and 24K in the other box. And now last thing I need to do is figure out what's on the outside. But it's not going to be as simple as starting off by putting K and K here, because K times K would not give me this 3K squared in this top left box. So there's going to have to be a 3 on one of these. So it's going to have to be 3K times 1K. If I'm looking at where the rest of the values are in the box, the 3K would have to go on the top of this column, because it's going to allow me to do some multiplication here in a second. So last thing, now that I've got 3K and K, K times what goes up here gives me 7K. So that is simply just going to have to be the number 7. And then this is why I chose to put the 3K on the top column here. 3K times this is 24K. There is a number that would work there, and that is 8. If I put the 3K in the other spot, it would not work, or I wouldn't have a whole number to place there. So I have my two factors, so I'll write them out now. Final answer, one of the sides is 3k plus 7. So that's one of them. And then the other side is k and a positive 8. So I'll write k plus 8. Okay, so again, we're just trying to get a refresher of how all of these kinds of problems work here using the box method and the X method. So I apologize if I ran through that a little fast. Feel free to pause and feel free to rewind or go through those again if you need to. But otherwise, the rest of the time today, you have to work on the rest of this worksheet, and then that will be due on Monday. If you have any questions over any of this, I will be sure to answer those when I'm back next week.